Now the next topic to look at preparing for A-level is the discriminant. Now you're all aware of the quadratic formula for solving a quadratic when it's equal to 0. So if I've got ax squared plus bx plus c and I want to know when is it 0, then we tend to use this formula. However, what we're going to look at is we're just going to look at one part of it, and that is the bit under the square root sign, because that has special properties. So it is known as the discriminant, b squared minus 4ac. So there are three situations that we need to look at for b squared minus 4ac. The one that you are used to mainly is that it is greater than 0, i.e. you end up with a square root. And when you put that into your calculator, you come out with two solutions. Now what you're finding is that on a given x-axis, when it's greater than 0, you'll come out with two places where it's equal to 0. So you have two distinct solutions, and that's what you mostly saw at GCSE. However, if the square root is equal to 0, what you find is that actually you could have factorised the quadratic, because you come out with one solution which is repeated, i.e. if you were to factorise it, you'd come out with two brackets which would be identical. So you have equal roots, one root basically. And then the third situation is that it is below 0. Now, if you try the square root of a number below 0 on your calculator, you get maths error, and that's because the results are purely imaginary. Or what I mean at this stage is that if you were to draw the graph, you would find that the graph does not cross the x-axis at all, i.e. there's no solutions. Okay, so here we just have three examples where we're just looking at the discriminant and determining whether it has the two solutions as suggested, one solution, or no solutions at all. So if I look at just b squared minus 4ac, just look at the discriminant. So b squared, 1 squared, minus 4 times a is 1, times c is 10. So we've got 1 take 40, we've got minus 39. So in that situation, we have no solutions. Repeat it for this one. So we've got b squared, so we've got 10 squared. Take 4 times a times c. C being minus 1 this time. So we have 100 plus 4, we have 104. So here we have two solutions. Calculate a job for the last one. We've got b squared is 36 squared. I never write the fact that that's minus 36 squared, because if you do that on the calculator without brackets, you'll get it wrong. So you just got to know that a negative squared is exactly the same as a positive squared. So b squared, I always just put the number, not the sign in front. So 36 squared minus 4 times a times c. So we put that into the calculator, 36 squared. Take 4 times 81, and out comes nothing. So we have one repeated solution. So the kind of problem that they tend to give is they tend to put another variable in there, in this case k, and they tell you how many solutions there should be. And therefore, from this equation, you end up creating another equation to solve. So it says that we have equal roots. So we've got to look at b squared minus 4ac equal to nothing, because that's what we have for equal roots. So b squared would be k squared, because we've got k lots of x, minus 4 times a times c would give us that this time. And again, we do want that to equal 0. Now, I've got to tidy this up first. So we've got k squared, 4 times 1 is 4. So we've got minus 4 times k minus 4k. And we've got minus 4 times 3, we've got minus 12. And that's equal to 0. So as I've said, this one equation with the information given provided us with another equation to solve. Now we can factorise that. K squared. 12 can be written as 2 times 6. And as long as the 6 is a minus and the 2 is a plus, that will give us the minus 4k in the middle. So there are two solutions for k here. K can equal minus 2, or k can equal 6. Now, if k was equal to minus 2, then we'd have x squared minus 2x and minus 2 plus 3 plus 1 equal to 0. That would provide us with x minus 1 all squared equal to 0, so x would equal 1. However, if I put in x equal to 6, then we would have plus 6x, and 6 plus the 3 is 9, and that would factorise to x plus 3 all squared, so therefore x would equal minus 3. Okay, so here's another one. If we have no real roots, then b squared minus 4ac must be below 0. So b is a 4. 4 times a times c. Now c is the constant, which is those two quantities there. If we remove the bracket but leave the 4 outside, then we have k squared plus 10, 2k, 5k, so we've got 7k. Now we could times everything by 4 and tidy up. However, I know that with that being a 16 and 0 on the other side there, I can divide everything by 4 and make life a little easier. So 4 goes into 16 4 times, it goes into it once. However, I keep the bracket in place there until I'm ready to tidy up completely. So there I've got minus k squared. Then I've got minus 7k. And 4 take 10 is minus 6. That's below 0. Therefore, if I put everything on the other side, k squared becomes positive, minus 7k becomes positive, and minus 6 becomes positive. If it's all over here, it's now greater than 0. Proved. To find the range of values for k, we then continue from that and, in this case, factorise with plus 6 and plus 1. So we've got critical values at minus 6 and minus 1, which we know from our GCSE days that if I put them on a x-axis line with the curve in, minus 6 is there, minus 1 is there. I want greater than 0, so that's this bit and this bit. So the solution is that k must be less than minus 6, or k must be greater than minus 1. So very similar to the last one, however with equal roots, we need to look at b squared minus 4ac equal to 0. So b squared minus 4 times a times c. So here we have 64 minus 4 and minus minus is that plus k equal to 0. So miss the 4 off. So 4k must equal minus 60. So k must equal minus 15. So this one is very similar to the last one in that we end up with an equation that involves x and another constant, in this case c, not k, but the maths is very similar. Now, if we had a straight line and a curve and we wanted to look at the points of intersection, we'd solve simultaneously. So if I solve simultaneously, y is x squared plus 6x plus 7, so I can replace that with what I've just said, equal to 2x plus c. If I rearrange that to equal 0, then we have that x squared plus 4x plus 7 minus c equals 0. Now, if it's a tangent, then it means that there's one repeated root. So in other words, we've got to look at b squared minus 4ac equal to 0. So b squared minus 4 times a times c equal to 0. Well, we got 16 minus 28 minus so plus 4c equal to 0. So here we've got minus 12, put it on the other side, it is positive 12, and that's 4c, so c works out to be 3. So if c is equal to 3, then put 3 into there, into this line here, we get that x squared plus 4x plus 4 equals 0. Now we know that that should factorise to bracket squared, i.e. bracket, the two brackets should be the same, and it does, because we get x plus 2 times x plus 2. So that occurs when x is equal to minus 2. And if I put minus 2 into either of these two equations, bear in mind that we know that that's now 3. So if I put it into this one, 2 minus 2's we've got minus 4, plus the 3 we've got minus 1. So y equals minus 1. That is the point of contact of this tangent. So the answer to A we have up there is 3, and the answer to part B